Welcome back, everybody. In our first technical session for the class, we're going to be talking about switched infrastructure and VLAN technologies. But before we get into that, I want to show the topology that I'm going to be using in Viral. And like I mentioned, I'm using this on Packet.com, which is a cloud hosting provider. And the specific .viral file is going to be under repositories, the INE-Viral repository, which you can add with our URL that's github.com/internetworkexpert/INE-viral. And this is currently under CCIE RSV5 Workbook, Advanced Technology Labs, and then Basic IP Addressing. So I'm going to be setting up some additional folders in here for enterprise infrastructure, but effectively what the topology is going to look like is this for 10 routers, and then we have 4 switches on the side that are in a full mesh and then have one connection to the virtual switch that's then connecting to the 10 routers. Okay, specifically in this section, we're going to be talking about access ports, or what are the different port types that we have on the switches. So access ports, .1Q trunk ports, dynamic ports. We'll look at VLANs, standard VLANs, extended VLANs, and the VLAN database. And then we'll talk about trunking with dynamic trunking protocol, the native VLAN, and then editing the trunking allowed list. Now the Ethernet port types, we could break these down into 2 different categories. We have our layer 2 switch ports and we have our layer 3 ports, where the layer 2 access port is going to be 1 VLAN. The layer 2 trunk is going to be multiple VLANs. The layer 2 tunnel is going to be for a .1Q tunnel. We'll come back to this later. And then dynamic is going to be to dynamically negotiate trunking with the dynamic trunking protocol. For layer 3 ports, we have our switch virtual interfaces, which are going to be our interface VLANs. And then we also have our native layer 3 routed interfaces, where we say no switch port at the port level, and then we could apply an IP address directly onto the interface. So as I mentioned, access switch ports, those are 1 VLAN. Trunk switch ports are multiple VLANs. Tunnel switch ports are going to be a transparent layer 2 VPN, and dynamic switch ports are going to have DTP negotiation. So for layer 2 trunking, we're focusing on just .1Q, which is the open standards for trunking, and the native VLAN is going to be sent untagged. Dynamic trunking protocol, or DTP, we're going to verify this with show interface trunk, show interface switch port, and show spanning tree for the VLAN. So let's go ahead and jump over to the topology here. And right now we have switch 1, 2, 3, and 4 connected together. And if we look at the show CDP neighbors, we have a full mesh of connectivity that's going to the switches. So we have 3 ports between each of them. Show CDP neighbors. And I need to turn off domain lookup here. Show CDP neighbors. Okay, so we have a full mesh of connectivity between the 4 switches. Okay, the routers, on the other hand, are all attached on a single trunk port, which is gig 1.3. So first thing we're going to do is set this to be a .1Q trunk. Okay, if we look at currently the show interface gig 1.3 switch port, it says that the administrative mode of the port is dynamic auto, which means that DTP negotiation is on, but it's only listening for someone on the other end to form the trunking negotiation. Based on the result of this, the operational mode was static access, because no one tried to negotiate trunking from the other side. The trunking encapsulation can be negotiated, but the operational trunking encapsulation is native because this is an access port. It means that it's not doing any tagging on the link. So even though the negotiation of trunking is on with DTP, since we're running in dynamic auto mode, none of the switches have negotiated trunks to each other. Okay, we could also see this when we look at the show interface status, and it shows us that we have all the ports in VLAN 1. Okay, so a couple changes that I'm going to make here on switch 1, interface range gig 00 through 3, we're going to set the switch port mode to dynamic desirable. Okay, on gig 1.3, which is the port that goes to the routers, if we do show CDP neighbors, Okay, gig 13 is the port going to all those routers. We're going to set this as a static trunk. So interface gig 13, switch port mode trunk. And it says an interface whose trunk encapsulation is auto cannot be configured to trunk. So we also have to say the switch port trunk encapsulation is either ISL or .1Q, because the default there is to negotiate. Okay, switch port mode trunk. And if we now look at the show interface status again, we should see that some of the interfaces negotiated to trunks, these are going over to gig 0, 1, 2, and 3. Gig 0, 1, 2, and 3. These are going over to switch 3. Okay, if we show interface status again, we're going to add this to the other link. So interface range gig 1, 0 through 2. Switch port mode is dynamic desirable. Okay, if we now look at the show interface switch port, let's say gig 1, 0 switch port, it says the administrative mode was dynamic desirable as opposed to dynamic auto. And the end result is that we did form a trunk. We're negotiating the encapsulation, and it tries to negotiate ISL encapsulation first because the negotiation of trunking is on. DTP negotiation, it's enabled on some platforms by default. We saw here that it was running in dynamic auto. Some switches run it in dynamic desirable by default. So it means that you just wire the switches together and they automatically form trunk links. In this case, we have to have some other user interaction in order to actually get the trunks up. So desirable mode is going to be initiating the trunking negotiation under switch port mode dynamic desirable and switch port mode trunk. Dynamic auto is just passively listening for the trunking negotiation, which is the switch port mode dynamic auto. Now, if we wanted to turn DTP off, a couple different ways that we can disable it. One is going to be with switch port no negotiate. Access ports in turn have DTP disabled, as do tunnel ports. And we can verify this with the show interface switch port. So on switch 1, we have that interface that's going to all the routers, show CDP neighbors, which is gig 13. If we show run interface gig 13, we have switch port mode trunk statically defined, but if we show interface gig 13 switch port, we'll see that the negotiation of trunking is still on. So if we were to do a capture of the link, we would still see DTP messages going across. If we wanted to further disable this, we would go up to that port, so interface gig 13, and say switch port no negotiate. If we now show interface gig 13 switch port, now the negotiation of trunking is off. Okay, the reason we needed to do this here is that the routers on the other end don't support DTP. So you could leave the negotiation on as long as the static mode is set to trunk and the encapsulation is set to .1Q. But it really depends on what the exam is asking for here, if we want dynamic negotiation to be enabled or disabled. Okay, so next let's go ahead and set up some layer 3 ports. On switch 1, we're going to configure interface VLAN, let's say 146, between routers 1, 4, and 6. And these routers have the address of, let's see, show IP interface brief. We have 155.1.146.1. So on switch 1, we're going to say our address is 155.1.146.21 and no shut the VLAN. Okay, if we now show IP interface brief and show IP route, we should see that we have the VLAN installed in the routing table. Okay, from this output, it looks like something's wrong. It says that the VLAN is in the down and down state, so we're not able to route packets across it. So let's ping 155.1.146.1 and we're unable to reach it. Okay, anybody know what we're missing here in addition to creating the trunk link, creating the VLAN, and applying an IP address onto it? Okay, the key step is that we forgot to create the VLAN. So the VLANs are going to generally fall into three categories. We have standard VLANs, extended VLANs, and internal, where the standard VLAN range is 1 through 1001. 1 is going to be our default Ethernet access VLAN and the default native .1Q VLAN. So we can't delete this, but we can manually prune it from trunk links, but it cannot be pruned by VTP. We would have to be pruning it manually. Generally, you should not use this for the port assignments because everything is going to fall back to VLAN 1 by default. Okay, so we need to configure this VLAN 146 in the database. Two ways we could do this. We could either go to the VLAN database and we can configure VLAN 146. Okay, if we now show IP interface brief, hopefully the port is now up. Okay, the port is up, and now let's ping to 155.1, 146.1, okay, which we have reachability. So the point being here is that when you instantiate the layer 3 port, it doesn't automatically create the actual VLAN construct. The other way that we could have seen this is if we create another VLAN interface, let's say VLAN 13 between router 1 and 3, interface VLAN 13, IP address 155.113.20 or 21, and we show IP interface brief. Okay, the port is shut down by default, so we no shut it. Show IP interface brief. It's still down. Okay, the other way we could tell this is by looking at the show spanning tree for the VLAN. It says the spanning tree instance doesn't exist. Okay, the second way to create the VLAN would just be to go to global config and create VLAN 13. This is going to create our MAC address table and it's going to create our spanning tree instance. Okay, notice that the ports are all in the designated state because we are the root bridge and we're currently in the listening state. So once we go through listening and then learning, we should go to forwarding on port gig 13. Forwarding. Okay, so now if we ping 155.113.3, we should have reachability. So just a couple minor caveats here. For creating the VLANs, we need to make sure that it exists in the VLAN database. So either you can do that in exec mode under the VLAN database, or we can do it in global config. But the point being is that when you create the SVI in global, it doesn't automatically create that VLAN construct. Now, another way to do this would be to assign it as an access VLAN. So let's say we have VLAN 23. And we go to gig 01, switch port access VLAN 23. It says the access VLAN does not exist, it's creating it. Okay, the reason why is that if we show VTP status, right now VTP is running in server mode. So anytime that you create a VLAN or that you assign a VLAN as an access port, it's automatically going to create it. Okay, the same is not true when we're in VTP client mode because only the VTP server can create the VLANs. So if we now go to interface VLAN 23, address 155.123.21, no shut, and show spanning tree for VLAN 23. We're now forwarding, so we should be able to ping 155.123.3. which we can. Okay, the other option we have here would be to create a native layer 3 routed interface. So if we go back to our viral topology on switch 1, on gig 03, we're connected to gig 03 on switch 4. So on switch 4, we're going to make this a native routed port, and on switch 1, we're going to make this an access port. And we'll choose this, let's say this is going to be VLAN 37. So if we show CDP neighbors, we have gig 00 going to switch 4. We'll say on gig 00, switch port access VLAN 37. Okay, notice again that it's creating the VLAN because we're in VTP server mode. And then the other end of this link, gig 00, is going to, actually that is the management port. So we need to look at gig 10. No switch port access VLAN 37. Okay, we want interface gig 10. Switch port access VLAN 37. Then on switch 4, interface gig 10 is not going to be a switch port. Okay, we can now put an IP address on here, so 155.137.24. No shut. And let's ping to 155.1.37.3. Okay, if we look on switch 1, let's look at the show spanning tree for VLAN 37. We're forwarding on the port. And let's see, show IP interface brief. This is port gig 10, show CDP neighbors. Gig 10 goes to gig 10 on switch 1. Show run interface gig 01 or gig 10. Switch port access VLAN 37. And we'll say the switch port mode is access. Okay, if we show spanning tree VLAN 37, we're now in the listening state on the port because this is not an edge port. Okay, we're now in the learning state. And finally, we're in forwarding. So hopefully we should be able to reach 155.137.7 or .3. There we go. Okay, the extended VLAN range, this is going to be 1006 to 4094. You can normally only use this in one of two cases, when either VTP is running in transparent mode or VTP is running in version 3. And not all extended VLANs can be used. Some of these are going to be reserved for internal usage. So when we created those switch virtual interfaces, it's actually taking a VLAN number from behind the scenes and using that for the internal assignment. So you would see that certain VLAN numbers, when you go to actually apply, it might give you an error message saying that this is already assigned for internal usage. Okay, this is what we're using for the native layer 3 switch ports. When we say no switch port on the interface, and then we apply an IP address directly. Okay, we should be able to look at the show VLAN internal usage. So on switch 4, show VLAN internal usage. So we used VLAN 1006 for gigabit 1/0, where when we show run on interface gig 10, this is our no switch port. So this is effectively the same as saying interface VLAN 1006 and then binding it to that interface. It just happens automatically for us behind the scenes that the switch is converting the syntax into this functional result. So the other issue is that not all platforms agree on the internal range. Some of them start at the bottom of the range and count up. Some of them start at the top of the range and count down. If we look at the show run pipe internal, this switch has the VLAN internal allocation policy ascending. If we were to modify this, VLAN internal allocation policy is descending, then show VLAN internal usage. Let's default this interface and recreate it. So default interface gig 10 and recreate it as a no switch port. And we now look at the show VLAN internal usage. Now we're using 4094 and down. So it just basically means that either at the beginning of the range or the end of the range, you have to give some leeway for the no switch ports. If we were to go to assign VLAN 4094, it should bark at us that it can't actually do this. So let's do show interface status. We'll say on gig 01, switch port access VLAN 4094. It says it's currently in use by gig 10, failed to add because this is a VTP error. So it could be a corner case in the exam where they say, hey, we want you to assign VLAN 4094, but if the VLAN internal allocation policy is set to descending, it's already starting at the top of the range and then working down, so some of those numbers might already be allocated. And we saw that it was not a disruptive change when I switched from ascending to descending. I needed to default the port and then reapply the config in order for it to change what VLAN number that it was grabbing. Okay, so as we saw, the VLANs can be created globally. They can be created in the VLAN database, or they can be created at the time of assignment, assuming that we are in the VTP server mode. So creating the VLAN starts the spanning tree instance, it starts the MAC address table, and then we can verify this with either the show VLAN brief, or show spanning tree. So if we show VLAN brief, show VLAN brief, okay, we can see the numbers that we have created here, or under show spanning tree for VLAN 146. Says that we're the root of the spanning tree, all the ports are in designated mode, and they're all in the forwarding state. Okay, now when we're trunking, the allowed list controls what VLANs will be forwarded over the link. The default is that all VLANs are candidate to be forwarded, so 1 through 4094. There's no administrative limit as to what VLANs can flow. And we can change this with the switch port trunk allowed VLAN list if we want to manually prune the VLANs. So on switch 1, if we were to look at the show interface trunk, we see that we have our static trunk link going towards the router ports that is allowing all VLANs, but it tells us which ones are actually being used. Okay, so let's say that we were to ping the 146 segment. Right now we do have reachability to it, but on gig 13, if we say switch port trunk allowed VLAN remove 146, and we go to ping to the destination, now the VLAN is going to be filtered. So if we do show run interface gig 13, we're effectively allowing all of the other VLANs. So you have to be careful with this syntax here, switch port trunk allowed VLAN. If I was just say 146, this means only 146. And you could potentially lock yourself out of the box, if you're connected remotely. What I want to say is switch port trunk allowed VLAN is all. Do show run interface gig 13. Now it goes back to the default. Okay, if we ping 155.1, 146.1, okay, now we have reachability again, after we go through our spanning tree listening and learning phases. Okay, so as a review here, the main commands we use were show VLAN or show VLAN brief. This is just going to tell us, are the VLANs created? Show interface status is going to tell us, are we trunking, are we a routed port, or are we an access port? Show interface switch port is going to show all of the details of the switch port. So is negotiation on? Are we trunking? Are we access? Are we using .1Q? Are we using ISL, etc.? Show interface trunk is going to show what particular VLANs are actually being forwarded. And then show spanning tree for the VLAN is going to tell us what interfaces are participating in spanning tree for that segment and whether they're in the listening, learning, or forwarding states.